So, as we talk about, what I'm here today for is everyday C sharp. So, what are we going to be trying to do here? And this is where I want to spend some of the introductory time, especially for the people who are already invested in .NET and you've been with us for a fair amount of this journey. .NET is now more than 20 years old. We were joking in one of the LDM meetings today. Some of these C Sharp 1.0 features, they're adults at this point. They've been around for a long time. So we keep adding things to the language. We keep making it better. That does mean it keeps getting bigger. So what that means for us as we're looking to move forward is what should you be doing now? So I've been defining and reworking some of the docs to say that everyday C sharp, it is the subset of features that almost everybody who's using C sharp should be using almost every day. These are the things that you're going to grab every day for any kind of algorithms you're writing, no matter what workloads you're using, whether it's cloud native, a console app, that WinForms app you're supporting, WPF, web forms, MVC, whatever. These are the things that you're going to use all the time. And it's this intersection of new and old things, and they're applicable everywhere. And why I really want to talk about that is that there's some natural biases we have on that. I will have people come up to me and say, should I be redoing everything that I've ever done because now there's all these new features? And no. So the first rule that we're going to have is everyday C sharp doesn't mean edit all your code now and replace all the old things with all the new things. Because there's an incredibly high bar that the C sharp team has for language compatibility. And I just want to briefly show one of the things on here. This is the entire list of breaking changes in the C sharp language for C sharp 12. There's one. Okay, and the only one is that if you have a ref argument, you can pass it to an in parameter. That used to not compile, and now it does. So chances are you don't even hit that breaking change because it was code that wouldn't compile before, and now it does. In 11, we did have more. But if you want to go through these features in this area, what you're going to find is these are some really odd edge cases that we've had very few people really even hit this page and see these. And why that's important is as we look at what we're trying to do, and when you say, hey, here's what everyday C sharp is, here's the subset I'm teaching new C sharp developers today. It very much does not mean go back and, you should redo everything in all of your apps. If you've got an app that's working, you're probably doing some active development on it. Adopt these areas as you update parts of the app just naturally because it's new features or it's bug fixes that you need to do or it's refactorings you want to do. Then adopt the new things that we're talking about. So it very much doesn't also mean use only the new features. The old stuff, you'll never hear me say that old features are deprecated in the language because they're not. They still compile. It also doesn't mean, we're going after one of these biases we have is that for those of us who have been in .NET for a long time, the new syntax looks new and it looks different. So that feels harder because we've known these old techniques for 10, 15, 20 years even. And these brand new things that just got released in C sharp 12, we haven't seen them for that long yet. Even if you've been following previews, they may have only been live for a few months. So everyday C sharp, what I've been doing is I take this idea of if I were teaching someone brand new to C sharp today, what would I teach them? Some newer features are great beginner features. They're great to just start out, and that's the way you should code and write code today. Older features may not necessarily be easier. So we're going to say what we want you to do is as you're writing the code that you're writing and updating your application, start incorporating these. Some of these you may want to take one PR and say, I'm converting this entire folder to file scope namespaces because then I get those extra 4 columns back and it's just easier to read. And that way it's just one PR because there's all the white space diff everywhere up and down the page. Other ones, it's like, I'm only updating this class. I'm going to start incorporating some new features. So we're going to start to roll with those kinds of things. But it doesn't mean, it very much doesn't mean, go redo all the stuff that you've been doing. So let's spend some time, and I want to talk about some of the things that we've been doing over the last few releases that I think are some of the key things that I'm starting to teach beginners, and I would recommend adopting in everything that you're doing today. So I'm going to start with a feature we've done for um, in a few areas. I'm going to do this in SharpLab. I'm going to talk about records. So what we're doing with records is this is one of the ones that's confusing more for the people who've been with us on this journey, because we added records, then we added record structs, and now we've added primary constructors on every type you can create. And that can be easy, it's easy to get caught up in thinking about them based on the order that we added them to the language. And that's not the best way to think about them. Instead, think about it as a record is a way to say, for the compiler, please write all of these methods that I want to support value-based equality in either a class or a struct. And here's what I mean. Let's look at this. We have a person. I've got first name, last name, age. I've got their date. And I've said that the first name and last name are required. You have to set a person's name. And then we'll allow you to change it later. Maybe we don't know their age for this app. Maybe we don't need to know their birthday, but we've got something in place. And we can see what the compiler generates for this over on the right side. It's got backing fields for our auto-implemented properties. We've seen those for several releases. We've got a constructor that's going to be marked as obsolete because we maybe don't need it. And we've got the compiler generated things as a SharpLab thing just to show that the attributes that are used. Now, if I add the record modifier here, and now if we look at what the compiler generates, okay, some of these we've seen that we saw before, and now there's this equality contract that returns a type. Okay, that helps implement value-based equality. If I'm comparing a person, or maybe something where a person is something derived from a person, make sure that they're the same types. And we call the equality method on the most derived type. We still have our same properties. And then we get to a lot of other things that the compiler implements for it. On a record, the compiler adds toString. It's going to append the type name, which is person. It's going to put this bracket. And then it's going to call this print members method that takes this string builder, and then it's going to append a space, and then eventually it puts the closing bracket in place. And if we look at print members, we can see that that's virtual. So now any derived class is going to add its own print members that adds its own additional properties that it's printing out, and then it'll call the base class, and you'll get this really nice structure of printing out all the members in this record. We've got an operator not equals. We've got an operator equals, both of which are going to do the correct thing. We've got a get hash code that's pretty much going to be a pretty reasonable get hash code based on the types of your properties. I'll explain a little bit more on that in a sec. We've got the override for object equals that checks the object as a person and returns the right type. And it's got the virtual bool equals, and it's got a clone method that is compiler generated so it can support withers, and it's got a copy constructor. So just by calling it a record, we've added all these things. Now, these are great defaults. And now I specifically mentioned the get hash code member because if you really, really want to do some performance tuning, and if you really know some things about your type, the hash code method that the compiler generates is going to be based on the types of all the properties. So age being an int, it's got a range that probably isn't reasonable for a person, because it goes up to those, a full 32-bit integer. So you may find, if you do some performance testing and you do some tests on your type, that you can do a better hash code because the age, maybe it's for, the app Dustin and Mad showed yesterday where it's mostly students. Maybe they're mostly between the ages of 15 and 25. Maybe it's, some other database where it's all people who are between 40 and 70, whatever it is. You may have a different range. and you may want to do something slightly different with some of the properties. What would happen is if you did add one of those, then the compiler would use your method instead of the version from the record. So the way to think about records is you have value-based equality, and the compiler just automatically remembers all the methods that are part of value-based equality, equals, not equals, get hash code, um, you know, doing it up and down a hierarchy, and withers so that I can do non-destructive mutation. Now, in the same way, if I make this a struct, now I'm going to have some different things in here because now it's a struct. Once again, it goes back a lot closer to the things that we were doing with just the class. We've got our compiler generated backing fields, we've got our properties, and so on. And then if I make it a record struct, I'm going to get much of the same methods, but there's going to be a couple subtle differences. One of them is that print members is no longer a virtual method because I can't derive, more structs from this. And the other one that changes a little bit, that's pretty much it. We don't have a type comparer method either because we don't need one. Once again, because we don't have that inheritance hierarchy. So we've added these things that make it easier to do just pure data when you want value-based equality, and go ahead and use them. So now let's move over into Visual Studio and let's look at a couple of the other things that we really like. The other one I want to talk about is collection expressions. So if you look at historically, we've had different ways that you could initialize a collection. We have to new up an array and we give it values inside curly braces. We can call array.empty to make an empty one. We can put it inside some other parameter, as expression and make it something new. We can do lists the same way. We can make a span. We can make a span that does a stack alloc, and so on. All of these things, you have to remember which way do you want to do it, depending on the performance characteristics, depending on what type of collection it is. Well, let's just change these now. So if I want to use collection expressions, and we have a nice little handy refactoring now, that should be here. And it just looks like that. I now have something that looks like an array, square brackets around it, just the elements that are in it. I can do the same thing with no matter what the type of collection is. My array.empty, I now have just an empty collection expression. This one where I'm doing bytes, and I'm putting it inside a parameter. Okay, my argument is now this collection expression. And what will happen there, since write byte array, if we scroll down a little bit, that takes an array of bytes. That's going to create an array. So it's going to take that collection expression and then say the type that's expected is an array. So let's create the array. If I've got my span here, you can see we have the stack alloc here. Because I wanted that on the stack, I'm going to make it a collection expression. I don't need to remember to use stack alloc to get something efficient that doesn't allocate an array and put something on the heap that may need to get garbage collected. This one is really rather important. When you use collection expressions, when you update to that new feature, the way it has been implemented and the way we spec'd it out, the compiler can choose the most efficient way to construct the collection type that's needed. So in this case, you're trying to make a span. It's a span that doesn't escape, this method. I'm using top level statements, so the compiler is generating a main method for me. And that date span doesn't escape that method. So it can be allocated on the stack and avoids an allocation, and then it just goes away when it's gone. Same thing here when I call write byte span. I can make that a collection expression. I don't need to remember if I can put it on the stack or not. The compiler will do it for me. So I get a simpler syntax, and it's going to generate as efficient or more efficient code. And the final example on collection expressions is this one here where we're talking about the spread operator, that dot dot. So I've got two arrays of numbers, and then I'm just going to concatenate them together and add some more elements after it, and I've just made this collection expression that has more things in it. And this is one of the keys that we're trying to do as we move forward with any of the features we're trying to develop. We look at it in terms of, is the syntax easier than what you're already doing to solve the same problem? Does it write something that's more clear, or at least as clear, and maybe with less typing? But certainly clarity is one of the big variables there. And secondly, can we spec it out in such a way that the compiler can write the most efficient code possible? And you need to worry less about, is this going to be on the heap or the stack, or is it going to get allocated, or is it copied, and this and that. We really try to give the compiler the chance to do the best thing it can and make it as fast as possible. So that's collection expressions. The third one, which I think is one of the things that I really like in terms of where this can go for people who have got apps that have been around a while. So pattern matching lets us build something that's kind of like a set of if-then-elses, and we can just describe a pattern. So if I want to say, what state is water? Well, if it's greater than 212 degrees Fahrenheit, it's a gas. If it is between 32 and 212, it's a liquid. If it's exactly 32, it's transitioning between solid and liquid. If it's less than 32, it's transitioning to a solid. And I can rearrange these since they're all distinct and know that they always work. Okay. I can make them a little bit smaller, put them in different orders, use basically a discard pattern, say anything else can be the last one. Now, where this is really useful for you, if you've been developing an app for a while and you keep getting some kind of new, some new features show up, and you have to modify the app and you have to add logic. Pretty soon you can end up with something like this, almost 2 pages of code. So this is from a tutorial that I've got the link in one of the last slides. And the simulation is, you're doing this system to calculate tolls for a highway going into and out of a city. And after a few different iterations, the Department of Transportation has said, we really want to encourage people to use mass transit at different times. So we're going to increase the tolls at peak times, but only when traffic is the right kind of peaks. We want trucks going overnight, so nobody's trying to go in or out of the town. And we want people going inbound during morning rush hour to be, super expensive. Take mass transit instead. People going out of town, we want it to be expensive on the way home because we want them to encourage mass transit. And if you build this as an if-then-else, you start testing these different variables about what day or time is it, and are you going in or going out? And you've got all this logic. And that's hard to reason about. And it's hard to write good tests about because you've got these variables and you're tracing through if and else, and did you hit every branch and did you do stuff? So let's build a few small pattern matching elements, and then we can make it more clear and more simple. So I'll start with, say, I've got an is weekday switch. So I've got a pattern matching expression, and I'm just going to look at the date time dot day of week. And if it's Monday through Friday, it's a weekday. If it's Saturday or Sunday, it's not. Well, and I can even make this simpler now that I've just typed out every single time. I can say if it's Saturday or Sunday, I'm going to just remove all these extra 5 things. That's going to be false. And otherwise, no matter what it is, it's going to be a weekday. Okay? So now, I can start to simplify these if I do it. And then I can define an enumeration to say, what time band am I in? And then I can use pattern matching along with some or logic and some greater than less than, and say, if it's before 6 or after 7 at night, it's overnight. After that, if it's less than 10 in the morning, then it's morning rush. If it's less than 4 in the afternoon, now it's daytime, and it's evening rush if it's after 4 o'clock, but then before 7 because of the order of these. So that now becomes a small method. And now I can build this relatively simple table that has all the possible time bands and whether it's a weekday and whether you're going into or out of the city. And now I can build something that looks like this. Okay, that's got all the different cases in it. And then I can simplify a few things. Like I can look at all of these rows and go, anytime on the weekend, I've just said it's one. So I'm going to take the first one. I'm just going to replace the variables with the discard and say, all of these are going to be, one. And if you look now, I see red squiggles on the things on the arms later. And that means I can get rid of them. They've already been covered by the switch in front of them. And I can go and make quite a few more of these if I want to. And eventually you'll end up with something like this. And say if it's a weekday and it's overnight, you get a discount. If it's a weekday and it's daytime, there's a small premium. And if it's morning rush, you pay double. If it's evening rush and you're going out of town, you pay double. Anything else, it's just, that simple one by regular rate. Okay, so I've taken something that looks like this. You can see starts on line 26, 2 pages of code all the way to 71. At least we did put all the braces in there. I could take all those out and it'd be shorter, but even harder to understand. And I've turned it into the exact same code that is only 8 lines long, but it's 8 clear lines. It's easy to read and it's easy to see what you're doing. Is it a weekday? Are you going in or out of the city? And what time band are you in? And I've got those 3 things, and that's all it is. And that's what pattern matching adds for us. It gives us this way of being able to break down our if then else logic or some other logic and control flow and go, I know what I'm trying to test, and let's just build an expression for it. And then what pattern matching does with a switch expression is it ensures 2 things. It ensures that you've handled every possible input, or you'll get warnings. And it ensures that every one of these switch arms is reachable. If it's not, then you'll start to get errors. Okay, so what did that mean in terms of where we're going? And what should you be doing? So I'm going to keep working on updating our docs. So the fundamentals for C# are going to really start to incorporate more of these concepts. That area is going to keep being updated to incorporate features that we think belong in everyday C#. And I only covered some of them. There's raw string literals. There's a few other things I think everybody should be using really early in their journey of learning C#. And that also means that you as an experienced .NET dev, go ahead and pick those up as you're writing code. Talked primarily about pattern matching and collection expressions, which is new in C# 12. Primary constructors, which Dustin and Mads talked about a lot yesterday. Can add some of that in here with more time. And record modifiers, when it's the right thing. It generates all those methods for you, but only when those are the methods you want. So what should you be doing in your project? Well, as you're writing code, when you've got a positive impact and you can say use pattern matching to make some logic simpler, use it immediately. Just take that opportunity and rewrite that. If it's nice, but it's minimal impact, schedule it and adapt it as you make some updates. Say, hey, maybe there's a point where I'm going to update to the next release and we've got all this code that's using different namespaces and extra brackets. Add file scope namespaces. It's just going to make it look a little nicer. And then most importantly, you should build a subset that matches your product. There are things I think I'm probably not going to include for everyone, like a lot of the ref safety features. If that's really important for your product, you should add those and say, we're going to just go all in on the perf stuff because maybe our app does a great deal of numeric processing or whatever. And so we're working with large data sets and I really need that. Or maybe you definitely don't want something we're recommending in general. That's totally up to you. So build a subset that matches your own everyday C#. So obviously download and get .NET 8. This latest release, we're really proud of it. We're happy. Look at what's new in C#. Adapt the features you want. You saw Dustin and Mads talk about that a lot yesterday. Look at the everyday C# GitHub project. There's where I'm keeping my notes as to what I want to add, how I want to rework the entire TOC for the .NET C# guide. I'm interested in your thoughts on this. And the pattern matching tutorial where I took that bit of the pattern matching example is right there in our fundamental section. go ahead and browse through that and walk through the whole scenario and see how we build everything. And with that, we're getting pretty much right there where we're ready for some questions.